In part B2, similarly, they ask us that which option should the player of the second round choose in order to maximize the expected number of tokens. So just now we calculate the expected value of option 1. We are now going to do similar thing for option 2, but it's just simply a little bit more complicated. So in option 2, there are 4 possible outcomes: 50 tokens, 10 tokens, 5 tokens, and no tokens. Again, similar in B1. For the case without any tokens, you can just simply ignore it because anything times 0 tokens will become 0. So there are 3 components we need: the probability to get 50 tokens. So the criteria are quite similar to the previous one. 3 balls fall into 3 adjacent tubes. So 3 balls in first one, second one, third one, or in the first tube, then it is 1/8 appear for 3 times in a row, so power 3. And then similarly, we have 1 place, 2 place, 3 place. Until 8th place, we have 8th place to fulfill this requirement. So finally, we time 8. Then this part possibility is 1/64. Finish 1/3 of it. And then the possibility of 10 tokens. They say that 3 balls fall into 3 adjacent tubes. So again, it's quite similar to option 1. But now every possibility have to use 3 space as 3 tubes. So first, second, third one, fourth, fifth, sixth. So we have 6 space to do so. First we have 6 space, and then they have to arrange it in 3 space, but among that 3 space can be 1, 2, 3, can be 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Or simplicity, that means 3 factorial. Divided by all possibility. First we have A choice, and then the second one, third one, we have A's power 3 choice to arrange the balls. So this possibility is 9/128. The last one is the most complicated one, the 5 token case. Similarly, we use 2 tubes which is next to each other, so that until the last one, then we have 7 space that we can choose. And then after that, you already limited the situation is 2 tubes together. And then now maybe like this, or maybe like this. So we are going to determine which tube have 2 balls, and then we have 2 choice, 2 tubes, right? So we choose 1. So this is among 2, we choose 1, or you just times 2, the same. After that, we have to consider, okay, now we already confirmed this 1, 2 balls. And then we have to think how to rearrange it. We have 3 balls, and then we have to put 2 out of 3 inside this tube. So the number of choice is 3C2. After that, you may consider that we have 1 tube left, so 1C1, and then we have 1 ball left, so another factor is 1C1, but you just simply don't need to write that down. Okay, that's the number of cases fulfill our requirement. Then we have to divide by how many numbers that you can rearrange the balls. Again, it's A's power 3. So the answer is 21/256 here. We get all 3 components. It's final round to get our expected value. Our expected value is the 50 tokens possibility times 50 tokens plus 10 tokens possibility times 10 tokens, and then plus 5 tokens possibility times 5 tokens. And you get the answer 485/256. this is the most difficult part of this question, and I think it's the most difficult part of this paper. The fact is, after 2014, really poor performance in this type of question, and then they didn't put so many marks in possibility anymore. And then in the recent few years, it's become easier and easier, more straightforward. Most probably, they just test whether you can use the fundamental combination, permutation, or some probability identity. Continue to B3. And then now they say that only the winner in the first round can play the second round. That means if someone loses in the first round, then no more. It's given that the player of the second round adopted to our option which can maximize the expected number of tokens. Just now forget to answer the question. Answer the question in B2 first. It seems the expected value of option 1 is larger. So we choose option 1. And then, so that means they imply that the winner in first round will choose option 1. Then we follow this formula. And then Billy claims that possibility of Ada get no tokens in the game exists 0.9. So we are trying to find out the probability of Ada get any tokens. So we need a tree diagram. The first stage is round 1, first round. The second stage, of course, is the second round. And then in the first round, there is 2 outcomes. Maybe Ada win or Billy win. That means Ada lose. And then in part second round, if Ada win, then maybe she have some chance to get the tokens. Just now we already calculate the probability to get 5 tokens or 10 tokens. So we just add them together, get tokens. And no tokens. What we care is the probability that Ada get no tokens. So if it's time to group all the things together, just now in part A, in the first round, Ada win, the probability is 6/11, and lose is 5/11 because they are complementary. And then we calculate this path because we want to know the possibility that Ada do not get any token. So after that, if Ada win, she will choose option 1. And option 1 only 2 cases, which is the probability of 5 tokens plus the probability to get 10 tokens. Then we just use the value that we have. Is 1/8 and then plus 7/32. That means 11/32. So another point of view, that means 21/32 do not get any tokens. We need to calculate this path together with this path. So the required the probability that Ada no token is equal to 5/11, or the second path, win the first round but finally still don't get any tokens. So it's 6/11 at the same time 21/32. Then the total is 0.8125, which is less than 0.9. So your answer that is that claim correct? The claim is not correct. So do not agree. The claim is not correct. Even a very complicated question like this for probability, a very important case is you must fully understand the flow of the whole of the situation. That's why you should spend longer time to understand, to make sure you know very clearly about every details, and then you can focus on certain part. For example, if you want the probability of certain case, then you just separate out and then focus on that part. Don't mess everything up together.